Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're talking about perpendicular straight lines. I want to start with a skill I need you absolutely good at. Pause the video and answer the following 4 questions, the following 4 products. Okay, hopefully, and without much bother, I would have expected you to get the answer was 1 for each of these. Now, that means you might need to go back to looking at your multiplying fractions or multiplying whole numbers by fractions, and also the idea of reciprocal, because I would have wanted you to spot that 3 and a third are the reciprocal of each other, negative a fifth and negative 5 are the reciprocal of each other, 3/4 and 4/3 are the reciprocal of each other, and so on. So I need you familiar with the idea of reciprocal and what that means. Two numbers are the reciprocal of each other if they multiply to 1. Now I want you to now pause the video and have a go at these questions. They look very similar, but the answers are a bit different. Pause and have a go. Okay, hopefully in each of these cases you spotted that you got -1. Okay, 3 times a third is 1, so -3 times a third is -1. And similarly, you would have got -1 in all the other cases. And these numbers are related to each other, and they're called the negative reciprocals of each other. The negative reciprocals. Okay, and two numbers are the negative reciprocal of each other if they multiply to -1. Now, if I gave you a number, say I gave you a number, I'm going to give you numbers A, and I'm going to ask you for the negative reciprocal. Say I gave you 2. How would you work out its negative reciprocal? Well, you would think of its normal reciprocal, which is 1/2. Or you could think of 2 as 2/1. Flip it, get 1/2, and make it negative. If I told you, however, the first number was, I don't know, -3, you could think of that as -3/1. You would flip it, and you would that would be -3. Then you would make it negative on top of that, and negative multiplied by negative gives you positive. So overall, that answer must be positive. If someone told you the answer 2/3, what's its negative reciprocal? You would flip it and multiply it by -1. If someone on the other hand told you you have 7/2, you would flip it and get -2/7, multiply it by another -1, and you would get yourself 2/7. So that's how you work out negative reciprocals if someone asks you. And we're going to need you to do that in this particular skill and henceforth. Right, then lastly, I need to talk about some key words for us. We know what it means for two lines to be parallel. Can you remember? So copy this down. Parallel lines must lie in the xy axis, and parallel lines never meet. They never intersect. That's the word for do not meet. They never intersect. They are always the same distance apart, and that's called equidistant. So for example, say I took a line like that. Imagine that went on forever, and I did another line like that. These two are parallel because they're never going to meet, and they are always the same distance apart there. Now there is a condition on the gradient about parallel lines we've already spotted, and parallel lines have the same gradient, and that was really important for us. Okay? Now what do you think it means if two lines are perpendicular? Have you heard that word before? Well, it's kind of the opposite to parallel. So because parallel lines never meet, these are going to meet, and more than that, so perpendicular lines do meet, they do intersect, and they always intersect at right angles. They form 90 degrees at the point where they meet. Now we haven't done angles yet on Hegarty Maths, but we do know a set of lines that are certainly perpendicular to each other. Imagine the xy axis, the x there and the y there. These two lines meet, they meet at 0, 0, and they certainly meet and form a right angle, 90 degrees there. So that's an example of two perpendicular lines. And what we're looking for in this video is there a condition on their gradient? When two lines are perpendicular, can we establish whether something is true about their respective gradients? And that's what I'm about to do now. So let me do a few examples for you to see if we can establish a condition for two lines being perpendicular and their gradients. Right, imagine we have a line here. Okay, what I'm going to do is I'm going to try and draw a perpendicular line to it. Now can you imagine, just for now, imagine that I drew a line like that and a line like that. and move them here and here. Would you agree those two lines must be perpendicular to each other because they are a copy of the x and the y axis? That must certainly be 90 degrees because it's 90 degrees there. Okay, so I'm going to use the x and y axis to draw a two lines 90 degrees, and I'm going to draw them here. So can you imagine that is like there? Yeah? Now, I've got my original line and I'm trying to draw a line perpendicular to it. So I know these two are certainly perpendicular to each other, right? Because they're like the x and the y axis. So if I take them and I try and twist them so that they're in line with the original line, the base of this is in line with the original, and I put it through there, would you agree that this line here must be perpendicular to the original? Because they now meet at right angles to each other. Okay, and let me clear that up for you and show it in a picture like this. The original blue line and the green line are now perpendicular because of this 90 degrees here. Now let's see if we can work out the gradient of the original line. So the original line, what's its gradient? Its gradient, well, as I go to the right one, I go up 2. So its gradient is 2. Now what about the perpendicular line? As I go across to the right one, I can't tell. As I move to the right 2, I go down 1. So as I move to the right 2, I go down 1. And its gradient must be negative a half. So you can see that 2 and negative a half are the negative reciprocals of each other. Okay? And maybe the condition for two lines to be perpendicular to each other is that their gradients are the negative reciprocals of each other. Let's try two more examples and double check this isn't just a fluke and it works in other cases. Here's another line. I'm going to start by drawing a pair of lines that I know to be perpendicular to each other. These two definitely are because they're like the XY axis. Can you see that? They're exactly like the XY axis. Now what I'm going to do is I'm going to take this and I'm going to try and twist it so that so the bottom of it is in line with the blue line, and I'm going to put it through 0, 0 like that. And now this part of the line here is perpendicular to my original line because they're meeting at right angles to each other. So let me clear that up and it will look something like that. So let's work out the gradient of my original line. The gradient of that, as I move to the right 4, I go up 1. So as I move to the right by 4, I go up 1. Its gradient is a quarter. What about the perpendicular line? Well, as I move to the right one, I go down 4. So as I move to the right one, I go down 4. So its gradient is negative 4. And again, these two gradients are the negative reciprocals of each other. Let's do one more to check that's actually true. So here's a line. I'm going to draw a pair of lines that I know are perpendicular there. And what I'm going to do is I'm going to take that and I'm going to try and twist it, okay, so that I establish a line that's perpendicular to my blue line. Taking it away, I get the original line there and the perpendicular line. So my original line, what's its gradient? As I go to the right 2, I go up 3. So as I go to the right 2, I go up 3. Its gradient is 3 over 2. And what about my perpendicular line? Well, as I go to the right 3, I go down 2. So as I go to the right 3, I go down 2. And again, they're the negative reciprocal of each other. So I've shown you in 3 cases, and this turns out always to be the rule. So let's state the rule. If we have two lines, two different lines, with m1x plus c1, so a different gradient here, and m2x plus c2, so they've both got different gradients and maybe different y-intercepts. They're perpendicular if when you multiply the gradients together, you get negative 1. Or you can say two lines are perpendicular if one gradient, m1, is the negative reciprocal of the other m2, or vice versa, m2 is the negative reciprocal of m1. And that's the key idea we're going to be using in particular in the next video. A little warm up for you just here before we go on. Pause the video and in each case state the gradient of a line that would be perpendicular to the lines with the following gradients. Well, if a line had gradient 2, then its perpendicular line would have its negative reciprocal, which would be negative a half. A line perpendicular to this would have gradient positive a third. The gradient of a perpendicular line to this would be its negative reciprocal, which would be -3. What about here? The gradient of a perpendicular line to this would be -4/3. And what about here? The gradient of a line perpendicular to this line would be its negative reciprocal. Flip it and multiply it by -1, so I'd get just 2/5. And we're going to need that skill for the next video when we solve problems about perpendicular lines. Thanks for watching.